Mike Isaacson. I'm the state hydrologist and hydraulic engineer. We last year we did this training on 449, and it was kind of a preliminary training, and since then we've updated the template for writing an irrigation water management plan, and done a lot of work on this and answered a lot of questions. And so this year's training, I think, is a little bit more complete as we address some of the needs that we've seen around the state. So appreciate you joining us here. Dr. Wang just emailed and says that she will be here at 9:15. So I guess we'll go ahead and proceed, Beth, with your presentation and introductions. So if you go to the next slide. Okay, so this is our agenda today. We're going to first have introductions, and then we will have Beth Peterson, our Assistant State Conservation Engineer. She's going to give an overview of the CPS 449 standard on irrigation water management plans. Then Dr. Wang will give a presentation on irrigation water management in Wisconsin. She's from the University of Wisconsin-Madison. They have a really good publications on this, and when it comes to irrigation scheduling, I believe their program is very strong, and the technical briefs and brochures that they have, it will be very helpful to you and to your growers. I will then give a discussion on writing an irrigation water management plan using the new template. And then we'll turn the time back over to Dr. Wang for soil moisture sensors, kind of an overview. And this is a repeat of what we did last year. We'll then talk about the WISP program and the WISP spreadsheet. And then we'll talk about scheduling for small plots and hoop houses. And so that's our agenda. And so if we can move to introductions, and I've kind of introduced myself, and Beth, why don't we have you introduce yourself?
I'm Beth Peterson. Many of you know me from my past life. I was the area engineer in Juneau from 2008 until 2020. And for the last year and a half, I have been in Iowa, being as a resource team lead. And I just came back 3 weeks ago, 2.5 weeks ago, and I'm starting as the assistant state engineer. So learning my new role, but I've touched irrigation water management and writing the plans quite a bit. I worked with John Vosberg when he was here. So this is not a new topic to me, but I am excited to be back in the engineering realm and excited to see new face or familiar faces as well as new faces on the call.
We'd like to welcome you, Beth, and we're glad to have you back in the state and in your new role. And Beth will be very much accessible for people to work with. Now, if you go to the next slide, Beth. So let's see. Oh, next week, yes, next week, March 23rd, we're going to have a training on irrigation assessments in Wisconsin. And here's the agenda that we're going to be talking about. And what this is really going to be focusing on is when somebody walks into your door and says, I want you to help with my irrigation system. This is a class for that. And in Wisconsin, our irrigation is usually supplied by a pump. And so the idea here is we're going to focus on pumping plants, and we're going to look at system demand curves and pumping plants, because that's how you assess an irrigation system, is you look at the water supply and you look at the demand and you try to match them. And really this is applicable for any pumping system that you have. You have always a system demand curve, and then you have a pumping curve. And so whether it's an irrigation pump or a manure pump or a livestock pump or a domestic pump for your house, it all works on the same principles and concepts. And so this training will be applicable for that. So that's next week. And we will start at 8 a.m. to 10 a.m. That way you can get into the field faster. If you go to the next slide, Beth. So the next training I would like to advertise is coming up in June 2022. I'm very excited by this. We are going to have a micro irrigation, and it's a 3-day training, and you don't have to attend all 3 days. It's geared to your interest level. And so June 13th, we're going to have an introduction to micro irrigation. If you want to know what micro irrigation, that's your day to come. And it's going to be held at the University of Wisconsin-Madison Agricultural Research Station. It's on the west side of Madison, just south of Middleton. They have a facility there that could hold 90 people, and we will have vendors there that could bring product, and we're also going to tour the university's drip irrigation systems in their gardens. We have John Chilcott and Kelly Scott from our national centers coming to do a training on the 14th and 15th, and the 14th is about planning and designing a drip irrigation system. And then on the 15th, we will actually do a project design together. This way, those of you who are interested in doing design, you'll be, once you finish this and complete this course, you should be able to do a design of a micro irrigation system. Beth, if you could turn to the next slide. So we already did the introductions, and we'll have Dr. Wang introduce herself when she comes. And so, Beth, I think I'll turn it over to you for your presentation, and I'll keep track of the chat.
Sounds great. I'm going to leave my camera off just to hopefully help with video connection on my end. Thank you, Mike. I'm just going to be involved in the first part of this training. I'm going to go through 2 things today. We're all going to go through 2 things. It's a 449 training, but there's really 2 things that come along with that. 449 is irrigation water management, but we also have to cover the plan that needs to be followed to implement that 449, the irrigation water management. So we need to write the irrigation water management plan so that it can be implemented using the 449 standard. So the old IWMP, most of the criteria could be found within 449 or under the old CAP 118, which was irrigation water management plan. That now has changed to DIA, the design and implementation activity 163. And that's still the irrigation water management design. It is the same criteria, well, very similar criteria as the old 118, but just know that you can reference that while you're trying to write the actual plan so that the landowners can follow 449. So like any standard, there's a definition and a purpose, and the definition really falls to how much water, when, and how quickly will it be applied, the volume, the frequency, and the application rate. And that's what's really covered within the standard. There, as you can see, there are 7 different purposes, but many times it's going to be the water efficiency, the poor plant productivity and health, or the reducing energy use. All of them can be used, and we should be talking to landowner to make sure we know what their main issue is. Those are the 3 common ones used, at least within Wisconsin. So the general criteria, again, going back to when is the irrigation going to be needed and the amount and the rate that water is going to be applied. Those are the 3 main things that are going to be talked about. So we need to base our timing of irrigation on 1 or more of those following: the evapotranspiration of the crop. You need to know what those crop coefficients, know the stage that that plant is in so that we know how much evapotranspiration is happening. We also could be basing it on the soil moisture monitoring if you have soil moisture sensors. Could be basing it on the computerized irrigation scheduling, using local real-time climate data, soil and crop growth characteristics, or just plant monitoring. So that's how we're going to determine when we irrigate. basing, what do we base how much we water? What's that depth that we need to water? We need to make sure that you're using the most restrictive crop rooting depth, but the available water holding capacity of that soil for that depth can be used. It can be difficult when you're dealing with like vegetable crops. So you need to know what that rooting depth is of that most restrictive crop. Use that to avoid water leaching down into deeper soil where the roots aren't going to be able to reach it. Management allowed soil water depletion. That's the MAD. What is that level of stress that landowner is okay with on those crops? You need to make sure you're filling that full bucket, that full soil layer. And when you're when that landowner is growing high value crops, that management level is going to be much more important than if that's corn and beans that you're out there watering. The volume of water needed for each irrigation could also be on the current soil moisture status or the current crop growth stage, the distribution uniformity of that irrigation event, the water table contribution, which happens some here, but not a lot. And then you also could be basing it on the computerized irrigation scheduling recommendations. Here's some more general criteria. For variable rate irrigation systems, you need to base that amount and the application rate of the irrigation on spatially identified field parameters. Some of these variations could be yield data, soils, crop growth, topography, but use that information if you're doing the variable rate. When the irrigation water is not available on demand, which isn't real common within Wisconsin, but it does happen, use that planned availability as the factor to determine the timing of the irrigation event. In all situations when the water is limited, when we don't have access to water all the time, ensure that the IWMP still will meet the critical crop growth stages. I've had a couple situations where the well just doesn't produce a lot of water. That's going to be a situation like this. Or if you're in a drainage district, there might be some situations that come into play. Not nearly as often as if you were out west, obviously. In locations where rain is expected during the growing season, mostly Wisconsin, and where the soil water balance is calculated, include measurements from an accurate method for determining that local rainfall. This could be an on-site rain gauge, an off-site rain gauge, interpolated predictions based on that local weather stations, some method of making sure you know how much rain, ideally some kind of rain gauge fairly close to the fields that you're actually watering, because we know how variable they can be. And then for surface irrigation, apply that at a rate that's going to get the right distribution uniformity, but not cause erosion as it's leaving the field. So that's the general criteria. Next, we're going to get into some additional criteria for different categories. The first one listed in the standard is protection of surface and groundwater quality. Really, this comes to that if you're irrigating on steep ground, if you put water on too fast or you put on too much water, it's going to erode. You need that to allow the time for the soil to be absorbed, the water to be absorbed by the soil. You may need to add other practices, either engineering or agronomic, in order to allow that water not to erode. You see on this picture off the side, it goes on too fast, it's going to run off. That's going to take nutrients, sediment, chemicals all along with it. If it's eroding, it's going to take all of that with it. Other criteria that goes along with the surface and groundwater quality issues. This whole long list, really, these additional criteria are primarily related to fertigation and chemigation. That's when you're putting on your fertilizers and chemicals through your irrigator. And really quick overview of all of these items. Really, you need to limit your time that you're applying the chemicals and the nutrients. You limit the application completely if you know you're going to have a heavy rainfall. And you also want to limit the application rate and volume to the amount necessary to apply to that proper depth. And make sure that system, if you're actually going to be putting the chemicals and nutrients in through the irrigator, that backflow valve is even more important to make sure that whatever your water source is isn't getting contaminated. Also, if you're using your actual irrigator for fertigation or chemigation, you need to be thinking about 590 and 595. You need to be following nutrient management and pest management if you're doing them through the irrigator. That doesn't get you out of that requirement. So some other categories that have some additional criteria within the standard. There's 3 of them that don't have a lot of information within the standard, but they reference you over to the NEH. It's managing salts in the crop root zone. You need to ensure that the irrigation application volume is sufficient to provide the appropriate salt balance in that soil profile. Again, go over for basing the required water volume in the NEH Part 623, Chapter 2, or the NEH 652, Chapter 3 and 13. Another category that the standard pulls out is managing air, soil, and plant microclimate. And for this, you need to provide protection from the heat and cold and ensure that the irrigation system can apply that required rate of water as determined, again, by NEH Part 623. And the third additional criteria category that you're going to find, actually the 4th for the grounded surface water, being number 1. The 4th category is to reduce the energy, and you need to provide an analysis to demonstrate the reduction of energy. If you're going to use how much energy is being saved on an annual or seasonal energy reduction compared to the previous operating conditions. Look and see how much energy was being used. Not on a 1-year basis. I think that we all have seen how much irrigation happens in 1 year, and the next year it's minimal at best. I've been out on sites that have they've only used the irrigator, the pivot, once a year or twice that year. And there are other years, obviously, they would be using it much more. So make sure if you're doing it for reducing energy, that you're looking at a good average and a current average. Don't look at back 10 years. Look at recent information. So some considerations that the standard pulls out when you're doing an IWM, and again, this is in writing an irrigation water management plan as well, you're going to increase that crop residue left on the field. This is going to reduce the potential for irrigation-induced erosion. It's going to increase the infiltration of the water into the soil, and it's going to reduce the evaporation from that soil surface. So all good things. Doesn't need to be just irrigation driven. There's a potential for spray drift and odors when applying agricultural municipal wastewaters. So time those irrigations based on the prevailing winds and reduce this potential. If you've got high visibility and you've got concerns, maybe do it at night, irrigate at night. The development of detailed topographic soil maps and the identification of environmental sensitive areas. This can help in the development of site-specific irrigation plans to better meet that crop need for minimizing environmental impacts, negative environmental impacts. So put together that layout of the land, the topographic soil maps. Plan the location of the end guns so they don't overspray. The overspray will not reach public roads and other unintended locations. I think we've all seen that as well. Think about where those end guns are going to hit when you're putting them on the end of irrigation, the pivots. Periodic inspection of those irrigated areas for the presence of pesticides, animal waste, and other contaminants. Before you irrigate, make sure there aren't things out in the field that are going to cause problems if they get wet and potentially run off. The quality of irrigation water can adversely affect crops and soils. Make sure that the water that is getting sprayed on there gets tested occasionally, that it's good for plant development and the pH, the salinity, just making sure that you've got good water that you're putting onto your crops. Avoid operating heavy equipment on wet soils to minimize soil compaction. I think those of us in the engineering side definitely see that as a plus. Sometimes you see the compaction just because of the irrigation water. If you see the tracks of the pivots going around, you're going to see compaction in those tracks. And then to reduce the potential for groundwater contamination, schedule salt leaching events to coincide with the low levels of residual, soil nutrients and pesticides. More considerations: manage the water so it does not drift or come into contact with surrounding electrical lines and components. Similar to the public roads, make sure you're staying away from electrical components, lines, anything for electrical safety. Consider how the consider how the interruption of power to that irrigation system from that load control. If that water can't get there, how are we going to deal with it? It could be power schedules, it could be maintenance downtime, it could be lots of different things. How is that going to affect my crop and if I can't get water out there? Some of them have irrigation systems that if they pause, they aren't going to get enough water to them because of the nozzle size or the speed of their pivot. So make sure that you're not that tight that if something does interrupt that use, the use of the pivot or use of any of the irrigation, that the plant's not going to be in trouble. The use of new technology for data collection. There's lots of things out there. Use it for yield monitoring, for data logging, lots of things. And the use of energy saving technologies, such as low energy precision application irrigation. Alternative energy sources can also do great savings on the energy side versus the conventional methods. And then crop species selection in situations where drought or water deficits are recurrent. So make sure you're thinking about all of these things as you're going through. They may not be applicable to all the plans that you're putting together, but at least read through them, think about it, and look at the site and make sure that you're thinking about something that might be unique. The standard cannot pull in all of the things you need to think about. Make sure that you're looking at it and talking to the landowner and any concerns they might have. So next section that we get into is the plans and specs. So at a minimum, a plan layout of that irrigation system should be in the plan. That could include irrigated areas, plant crops, soils, pipelines, location and installation information for soil moisture sensors, rainfall gauges, anything else that would be appropriate to get onto that map. Also include within your plans the method that's going to be used to measure the flow rate and the volume of those irrigation applications. Documentation of scientific method used for scheduling the timing. Again, all coming back to how much, when, and how fast. So the scheduling, the timing, and the amount of that irrigation application. The seasonal annual planned water application volumes. How much is the planned at least? Do we have that much water available? The management allowable depletion and the depth of the managed crop root zone. Again, this might vary. If you've got multiple crops in these areas, look for the worst case scenario. An estimate on the irrigation system distribution uniformity. What's it based on? Get that uniformity out there so that we know how even this water is going to come out across the field. Specific soil moisture monitoring objectives. If we're going to be using those soil moisture sensors, indicate how that data is going to be from the soil moisture sensor locations and depths, how it's going to be considered to make the field-wide irrigation decisions. Help that landowner understand that. And the last thing that the standard pulls out is the information on how to recognize irrigation-induced erosion and how to mitigate it. If you've got concerns about steep ground, if you know that you're going to be pushing how much water is going to be irrigated just because of restrictions otherwise, make sure you're thinking about that and where those areas might be. As I said, these are the items that are listed in the plans and specs portion of the standard. There's also the statement of work for the irrigation water management plan. And these are the items that are just included in the standard criteria related computations and analysis. That's the only portion that I pulled out of. But these are the things that we need to be looking at: that volume of water, the frequency of irrigation, the application rate, the environmental considerations. Again, where are my wetlands? Where are very risky areas? The soil and crop information, the location of the structures to be managed, the timing of the water application, the method for determining the timing and the amount. Well, how did you determine all that information? And then the method for determining the volume of the irrigation water needed. Again, wrapping back around to the standard, these are the things that we're trying to get so the landowner knows how much, when, and how quickly he can put that water on there. The last item in the standard is the O&M. And this part of the standard is really referencing the implementation part of the standard. If NRCS is paying for 449, the irrigation water management, it's actually the implementation of the irrigation water management plan. So that plan could be written internally or by a TSP, but 449 is implementing the IWMP. If the landowner wants payment to get an IWMP written, they need to be coming in and signing up for the DIA. If they want to be paid to implement that, they should be signing up for 449. So really, again, the O&M comes down to keeping the records. We're going to talk about this a little bit more a little later, but keeping the records of when they watered, how they determined how much they needed to water, when rain events happened, what their soil moisture sensors said. It's really the implementation of 449, as you can see as you're looking through that list. So that's what I had on going over the standard. Are there any questions?
We don't have any questions in the chat, but people could chime in. I do have a question, 2 questions for you, Beth.
Yeah.
If I wanted to come in and just do soil moistures, do I need a irrigation water management plan?
Now you're putting me on the spot. It might vary by program, and I'm not 100% sure on the program rules. I would say yes, you may not need to sign up for an IWMP. You may not need to sign up for it, but I would say that you should have one. Otherwise, the soil moisture sensors, how are you going to implement it? So you may not need to contract it, and that's a policy program thing I'd have to look up, but definitely you would need it. Otherwise, what are they going to be giving you? How are you going to be using them? How are you going to be implementing something from that? You need that information in the IWMP so that the sensors are giving you good data and you know how to follow it.
Very good. My second question is, if I like my irrigation system, I'm not asking NRCS for any upgrades, but I just want to get into 449. Can I have that as a standalone practice?
I think so. If you want to know how to implement your system better, we're just going to need all the information from your current system. But again, if you're going to do the 449, if you want to be paid on 449, you're still going to need an IWMP. You're still going to need a plan to know what to follow. And you're going to have to document and bring that documentation into NRCS to show it that you're actually following that irrigation water management plan. If anybody else who's done irrigation in the last year and a half in Wisconsin wants to pipe in, feel free. I may be speaking incorrectly on that, but that's my opinion, is that you wouldn't need to get a new pivot or new nozzles or anything of that sort. If you want to just use your current equipment more appropriately, I would think that that would be okay.
I believe that's correct. Matt put in the comment that the equip cookbook may state that you need an IWMP to get any irrigation upgrades, and that is true. So if you want to do a center pivot or a micro irrigation system, you need to sign up for 449. That's our policy, and I believe that's correct.
Do you need to sign up for it, or do you just need to implement it?
Oh,
Do you have to have it
yes.
contracted?
Do you want to explain the difference there?
And Matt, I don't have a cookbook sitting in front of me, a current one sitting in front of me right now, but so tell me if I'm wrong and misinterpreting something. What I've always looked at it is, and it really comes into play more in the micro than anything, but they have to be implementing irrigation water management plan, no doubt. If I'm going to pay for any kind of irrigation equipment, I need an irrigation water management plan that goes along with it. So they know how to operate it appropriately, get the best water savings they can, energy savings they can.
Hey, Beth.
The question
Matt,
comes into, do I need to contract that or can I just implement the plan? Go ahead, Mike.
That was somebody else.
Oh, I'm sorry.
Oh, can you hear me? This is Matt.
Yep, I can hear you, Matt.
Okay. I don't want to sorry to hijack this a little bit with the cost sharing, but I'll just say that it does say in there, an irrigation water management plan must be implemented and may be contracted for all areas where a sprinkler system like 442, for example, is installed. And I think that says that in a lot of the other, like the irrigation pipeline as well, and so forth.
Nope, that's okay to hijack it. It comes into question. So what I'm hearing, Matt, is they have to have a plan and they have to implement it. We might not contract it, so they may not have to turn in all of that data to us.
Correct.
Any other questions?
Beth?
Yes.
I can't see the chat, so I'm just going to add a comment like Matt did. Actually, Mike had asked about soil moisture sensors. The cookbook also states that if you want cost share for a soil moisture sensor, you're required to have irrigation water management plan for at least 1 year with it.
Okay, thank you. Again, I don't have my cookbook in front of me. I probably should have printed off those pages. I appreciate that input, Doug.
All right, any other questions for Beth? Well, thank you, Beth. Very good presentation, and appreciate your experience there. Dr. Wang has joined us, and so we will now turn the time to Dr. Wang, and she can introduce herself. She's with the University of Wisconsin, and she will talk about irrigation management in Wisconsin. I do want to say that I have put in the chat 2 brochures, 2 publications by the University of Wisconsin on irrigation scheduling, and they're most helpful and a lot of good information. And the programs that we do here in the state are based on these 2 references. Anyways, Dr. Wang.
Thank you, Mike. So how should I share my screen? I'm not using Microsoft Teams very often.
Okay, so do you see in the upper right corner the leave? The red leave box. If you go over 4 things, you see the 3 dots. Actually, no, excuse me. It's the next one over, the rectangle with the arrow. That's the share screen button.
Yep, okay.
Okay. And you pick your screen, and then I'll tell you whether we see it or not.
Browse my computer. Okay, all right. Permission. We need permission to share yours. Oh, here we go. Oh.
Let me see if I get you permission.
Security. Okay, all right. Microsoft Teams. Screen recording. I apologize for this.
No, this is fine. This is. Let's see.
Okay. Microsoft Teams. Okay. Will not be able to record the content of your screen until it is quit. Oh, I have to quit and reopen. This is just something with my MacBook. Sorry.
Okay. So we'll wait for her to come back on. Should be shortly.
Are there any other questions as we're waiting for her to come back?
So in our future discussions in this session, we're going to talk about writing the actual plan using the template that we produced, and then also using the spreadsheet, which is the implementation part. Yeah. That's one thing that was confusing to me, and I'm glad you clarified, Beth, that there are two parts here: writing the plan and implementing. All right, Dr. Wing.
Again, I apologize for all the technical hiccup. Let me see if I can share my screen now.
I think you do have permission.
Okay.
I
What?
did check on that.
How's my computer? Oh, shoot. Show out. I did. I was trying to.
If you want to send me your presentation, are you using the same presentation as Dr. Panuska did last year?
Nope. It's a different one.
Oh, I see it. I see it.
Can you see it now?
I do.
Okay. Why okay. So I guess we can get started now.
Yes, yes.
Okay.
If you could
So-
introduce yourself first.
Yeah, I will. Why I'm not seeing that on my end? But anyway. So
We see slide 7. Now we're on number 1. So,
okay, sustainable irrigation management.
yep.
Okay, all right. Thank you everyone for the opportunity today to present something about what my research and extension program has done over the last 4.5 years. I'm going to focus on the definitions and some of the key points today. Obviously, I cannot cover everything, so these just some of the major focus that I think important for irrigation management. So my name is Yi Wang. I'm assistant professor and state extension specialist focusing on sustainable vegetable production at Department of Horticulture, University of Wisconsin-Madison. And thanks, Mike, for the invite. So irrigation management is always going to be a key point when thinking about efficient agricultural production. And agricultural production always requires more efficient use of the groundwater for irrigation, and that's invaluable resource for producing food. With the changing climate, there are more and more extreme weather conditions like heat, drought stress, extreme like rainfall events that will all cause some adverse environment for the growth of the crops. Especially for heat, there's extreme heat, then the peak crop water use or evapotranspiration during some period of the growing season will increase, and that will pose some challenge to the agronomists for irrigation management. At the same time, maybe about 10 years or so ago, when there was a drought period here in the Midwest, we saw some drying up of the water bodies, especially the surface water bodies, that draw a lot of attention from the local residents to agricultural irrigation management. So we need to make the irrigation management more sustainable. And how can we do that? In my mind, sustainable irrigation management has two key components. One is to make sure that we have very efficient irrigation systems. And the second is that we have to be very smart about irrigation scheduling. For irrigation systems, we have to kind of maintain the good function of our current systems like center pivot or the linear move systems. At the same time, Beth mentioned variable rate irrigation. That's a very promising, efficient system that can probably help the agricultural managers to better use the water. For irrigation system, irrigation scheduling, there will be different approaches, such as the hand fill, using crop ET for scheduling the irrigation events and amount, or using soil moisture probes. So today I'm going to touch on each of those points, but I think I will really focus on the use of new technologies and how we can make the best use of those for efficient maintaining the irrigation systems and smart irrigation scheduling. So before we really start the presentation, I just want to quickly touch on some basic definitions about irrigation or water use. So there are three most important definitions here. The first one is field capacity. Field capacity means that the maximum amount of water a soil can hold against gravity. So the heavier the soil is, the higher the field capacity is. And then the second definition is management allowable depletion, or MAD, and that's the lowest moisture level that the plant can sustain without causing any adverse stress effects. Anything below this management allowable depletion level will be causing some plant water deficit symptoms. And if the water level keeps going down, then it will reach to the point of permanent wilting point, and that's the amount of water in the soil that most plants cannot survive anymore. So we definitely don't want the soil to be too dry. So the management allowable depletion is maximum amount of water we can, or the lowest amount of water we can have. At the same time, we don't want to have the soil to be too wet. So any water above the field capacity will cause soil saturation and waterlogging, and that in that way the water will fill up all the pores of the soil, and then there will be some oxygen deprivation problem, and that's also not good for the growth of the plants. So what is a good example of irrigation management? I have a graph here. This is from my colleague out west from University of Idaho, and he shared this slide from a potato grower, and we can see that this grower has been very successful in terms of managing his water available water level in the soil between the management of allowable depletion and the field capacity. We can see there's good spikes of soil moisture after each irrigation. It's consistent and uniform, and it never goes below the management allowable depletion level. Comparatively, there is a poor example of irrigation management where the grower kind of forget about the irrigation. This blue line here, it went way below the management allowable depletion for a couple of times during the growing season. And we just see those random spikes of soil moisture increase. Obviously, this is not what we want for a good quality and yield of crop production. So in terms of the irrigation systems, I mentioned that we need to make sure there is good maintenance of what we have or what the growers already have. Some of the tips include to fix the leaky systems, including the pivot pressure regulators and nozzles during the off season, like in winter or in the spring, turning off the end guns of the pivot, applying some newer nozzles that can generate larger water droplet sizes in order to reduce the evaporative loss. Summer days. Sometimes on some days there will be really windy situation, and those kind of larger water droplets during irrigation will obviously help to reduce the evaporative loss. For the new technology, variable rate irrigation is definitely a good option, especially for those folks who have fields with high variation of elevation or soil types, or growing different varieties in the same field. So just by telling from its name, variable rate irrigation means that instead of applying a flat rate along the pivot, the length of the pivot, VRI applies different rates of water depending on the situation in the field. If it's heavier soil or coarse textured soil, if it's high versus a low spot, or if it's an area in the field that needs more water for the variety. So depending on the situation. VRI might increase the irrigation water productivity, meaning the yield produced per water drop, and possibly water quality, just because we are managing the water more efficiently. And so just to keep the available water in the soil for the demand of the crops instead of being leached into the groundwater table. But I should point out that VRI will not reduce the crop ET. So if it's a high temperature, hot and dry day, it's going to have high ET anyway. So you got to make sure that VRI is meeting the water requirement of the crops. So far, the high cost of VRI is still the major hurdle for wide adoption by the growers. My understanding is that only those folks who have really highly variable fields will choose to install the variable rate irrigation in the fields. Most of them will choose not to, just because it's really expensive. The most common types of VRI include speed control VRI and nozzle or zone control VRI. So here are two graphs for illustrating the two systems. Speed control is very simple. It's just to change the moving speed of the center pivot to speed up or slow down when it's moving over the field. So when it moves to a patch of the field that does not need much water, then it can speed up. So it applies less water. And then when it reaches to a field portion that does need a lot of water, then it will slow down to apply more water. So the prescription will look like a pie slice, will have pie slice shapes of sections in the field, just because it's moving, is speeding up or slowing down. And a more sophisticated system is nozzle control or zone control. In this case, the VRI system is very flexible in terms of controlling how much water can be applied at different spots within the field. So the prescription here is highly variable, and obviously this system is going to be more expensive. For the speed control VRI, some of the newer control panels can be compatible with the conversion, so it's free for the conversion to switch from the conventional center pivot to speed control VRI. But the nozzle control VRI definitely needs some technical conversions, and so it's way more expensive. So here I have a short video just to give us more details, just illustrate how the VRI systems work.
Every field is different, with varying soil types and topography. Applying the same amount of water across your entire field doesn't always make sense. With easy-to-use Valley VRI software, growers can irrigate more efficiently without compromising yield potential by over or underwatering. Valley offers growers a choice of customizable VRI solutions, speed control, zone control, and individual sprinkler control. Valley VRI Speed Control utilizes existing hardware and adjusts the speed of the center pivot to achieve the application depth you want based on the customized irrigation prescription. For more challenging field conditions, there's Valley VRI Zone Control. By adding hardware, growers can control sprinkler banks for precise water application and to prevent irrigating ditches, canals, wet areas, or other spots. And for the most precise VRI option available, there's Valley VRI IS, which assigns each sprinkler its own flow rate. Your customized prescriptions utilize GPS positioning, shapefiles, and sprinkler package data to apply water only where you want it, reducing over-under watering and runoff. VRI is also ideal for varying water conditions, such as avoiding certain areas when running wastewater through the pivot.
So this video is not for endorsement. I just want to use this video to give you an example about how VRI works. So my research group has done some studies in 2018 and 19, collaborating with some vegetable growers in central Wisconsin. And we found that the VRI system is really efficient to keep the soil moisture level within the rooting zone. For the spots in the higher areas of the field, and then for the lower area, like that tends to get really wet most of the time. It's saving water and keep the soil relatively dry compared to the conventional center pivot. So VRI does work for those fields with variations, and we did see an improvement of yield for the crops growing in the high spots. So there are some benefits. Some other new technologies for irrigation systems. This is from the West, Pacific Northwest. Some of the fields are.
Dr. Wayne, could you share your screen again?
Oh, okay.
When you turned the video off, you turned off your screen.
Uh-oh.
That's all right.
Okay, here we go. This one. You're seeing it again?
I do see it.
Okay. So this technology is even more sophisticated compared to the VRI. So in this case, the drip irrigation tubes are attached to the center pivot. So when the center pivot moves around the field, they're actually dragging all those drip irrigation tubes or pipes along with it. And so it's kind of like a moving pivot, but with drip irrigation system. Really cool. The flow rate at each drop on that drip irrigation tube is controlled by length or number of emitters. In this case, because it's kind of like a drip irrigation system, so the canopy can always stay dry. And disease pressures and pest pressures can stay really over the course of the growing season. And this also reduces the evaporative loss from the canopies because of the drip irrigation feature. Because the drip irrigation tubes are moving along with the center pivot, there's no concern of foreign materials like the traditional drip irrigation. And then compared to the irrigation efficiency of center pivot, that's about 60%, 60 to 65%. This system can have up to 95% of irrigation efficiency. So really efficient use of water. And pivot rutting can be avoided just because we're avoiding the water logging. If for some reason there is a low spot. So overall, there are a lot of benefits of using this new technology. However, I did call the R&D department of this company, and I was talking with them. And what they told me is that for a Midwestern state like Wisconsin, there's no such need for a fancy system like this, just because we we don't have that, windy and dry days like out west. And so he just does not recommend using this. Because it's very costly, about 20 to 25K per pivot if using groundwater irrigation. And then it does have some drawbacks. The drip tubes can be damaged by animals or by the winter winds if not stored properly. Like I said, it's not recommended for Wisconsin. Most used right now, most used in Idaho and in Colorado, those dry states that have some more severe drought issues. Just want to introduce this to you so that you're aware of the existence of this technology. So next part, let's quickly talk about irrigation scheduling. The first method is called the hand fill method, which in order to use this method, you have to be really experienced. So it needs many years of experience with feeding the soil. It's just, by taking some soil samples from the field, usually by 3 different sites in each field. You take the soil samples and squeeze it on the palm of your hand. And referring to the USDA NRCS Program 8 number 1619, and there will be some figures and numbers to show you how moist the soil is. Usually, people will collect the soil samples by 1 foot increments, just to within the rooting zone and a little below the rooting zone, to understand the current status of soil moisture within the field. This method is really labor intensive and time consuming. And like I said, it needs a lot of years of experience to be able to successfully apply it. This is the screenshot of that publication with the title Estimating Soil Moisture by Field and Appearance. The next irrigation scheduling method is to refer to ET, evapotranspiration. In this method, we need 2 numbers in order to calculate the crop water use. One is to know the reference crop ET. Usually the reference crop is alfalfa. This reference crop ET is a function of weather conditions, including the solar radiation, air temperature, wind speed, relative humidity. And also we need to know the crop coefficient of the crop that we are interested in. And this crop coefficient is a function of the crop growth, and it's going to be different for different locations, even in the same state. So in order to accurately calculate the ET of the crop of interest, we need to know the reference crop ET and the crop coefficient. If any of those 2 numbers are incorrect, then there will be an incorrect estimation of ET that will lead to over or under irrigation of the crops. So the most difficult part of using this method is to accurately estimate the crop evapotranspiration. Next is to refer to the soil moisture level of the field. For irrigation scheduling, I will have a separate talk in half an hour to more specifically talking about soil moisture sensors. But this method is to use those sensors and understand the moisture level of the soil. Some drawbacks of this method is that it cannot indicate a spatial variability. So the soil moisture sensors are only installed at specific spots of the field. And also it's labor and time consuming to install and then remove the moisture sensors before and after the growing season. So it really depends on the crop type, the soil type, what type of irrigation systems you have, how much labor you have, and your financial budget and such. A lot of factors to consider if choosing different soil moisture sensors. The last one I just want to quickly touch on here is a new technology has not been really commercialized yet, but I think this is really exciting technology. So this is using the crop canopy temperature to indicate the crop response to the environmental water conditions. So we all know that stomata will close if there is a water deficit in the environment. So after it's closing, it's closed, the plant transpiration will reduce, and then the canopy temperature will increase. So with this knowledge in mind, some researchers have designed a sensor that can be mounted on top of the center pivot and moving with the center pivot within the field that can sensing the temperature of the canopies. So then there will be some machine learning models or algorithms that can tell the irrigation scheduler based on the canopy temperature from the sensor, like when to irrigate and how much to irrigate. This system has been successfully researched on cotton, corn, and sorghum on research plots. Like I said, it has not been commercialized, but people have seen a lot of promise of this new technology. It will be relatively costly at this point, but with more research down the road, I hope that this can be applied to commercial fields. So this is a picture of how the sensor is mounted. It's on the top of the center pivot and moving around the field. So just some summary, the pros and cons of each method. The field and appearance method is straightforward but labor intensive and requires experience. For ET, referring to ET, it's easy to apply, but lower accuracy than the soil moisture method, and it requires very accurate estimation of ET. For the soil moisture probe, the approach also easy to apply, more accurate than the previous two methods, but the maintenance and installation of the moisture sensors are going to be an issue. And for the new technology, it's just not there yet, but we will keep our eyes open. So just the last slide of this talk, sustainable irrigation management in Wisconsin always requires efficient irrigation scheduling that can tell us when to apply and how much water to apply. And at the same time, we need to make sure that we have very efficient irrigation systems so that we can apply the water in the right place. Keep in mind, new technologies are going to play a very important role in all of these in the future. So thank you. That's the first presentation.
Thank you, Dr. Wang. We do have a question, but it's probably for us to answer. Doug Denk asks if our programs will pay for all the three options you show for irrigation scheduling, meaning hand fill, using crop ET, or using soil moisture probes. The answer, Doug, is that we do not anymore offer a scenario that pays for the hand fill method. When people sign up for a CPS, a 449 and want payment, we want them to embrace technologies that allow them to measure data or to estimate data. And so using crop ET, which is the checkbook method, we pay for that. Using soil moisture probes, we pay for that. And we also have in our references the technology Dr. Wang talked about temperature sensors. If you read the reference, it's in there. And so I think we would allow for experimentation on that as well. So we have, I think, crop ET would be the WISP spreadsheet. Yes, the crop ET is the checkbook method. The WISP spreadsheet is one option to do the checkbook method. The WISP program is another one, or a consultant doing the checkbook method. That's another way of doing that.
Yeah, and for some of the growers, if they're working with the private companies, the company will also provide ET. They have their own system for calculating the ET.
Yeah, any other questions? Well, I appreciate it, Dr. Wang, and we will return to you here in about 10-15 minutes, if that's all right.
Okay.
I'll let you grab a drink.
Thank you.
I'm going to go to my presentation now. So just pause while we change horses here. Okay, do you see my screen, anyone? And I'm off the chat now, and so Beth, if
I
you
can
could.
see your screen and I will monitor the chat.
All right, thank you. I'm going to talk about writing the irrigation water management plan. And Beth talked about the basics, the standard of the 449. And so this is the first part about writing the plan of when a producer comes in and they go, well, I need a 449. And so you're going to go out to their place and look around and you're going to write a plan with them. I want to stress we write it for them, but we have to write it with their input. They will give their ideas out on stuff, and we'll talk about how that works. We're going to talk first about the references. Anything that we've talked about today, including Dr. Wang's stuff, is in our NRCS references. I use the University of Wisconsin publications because it's really tailored for our state, but the references are compliant. The university's references are compliant with our standards and references. I've checked them out. We're going to talk about the template here and what the plan components, which Beth has already talked about. Then I'm going to talk about a little bit about cranberries. They're a little different animal here, or a different plant. Guess I need to use this right right species here. So in our references, these are the references we have, and they're found. They're publicly available to anybody. Anybody could download the stuff. And Part 623 is a good one. We also got Part 652, Chapter 9. Of course, our standards and scope of work, which Beth went over there. When it comes to flow measurement, the Bureau of Reclamation has their water measurement manual. And Chapter 14 is for pipe flow, measuring pipe flow. That's what NRCS uses. And I'm highlighting the irrigation publications the university has, and when you go to a site, I would print these off or refer your producer where to find these. These are well written, they're graphical, so people like me can understand them, and I've seen them used with
Mike,
high success.
you're breaking up some.
Oh. Okay. I will try to, I don't know how to deal with.
You're okay right now.
Okay, thank you. So the template for irrigation water management plans, we have it under review right now, but it is going to be located in the FOTG section 4 under CPS 449. The title of it's going to be that 449 Wisconsin GD Irrigation Water Management 2022. If you need an irrigation template right now, get a hold of me and I will send you one. I'll send you the one that is under review in that. But we've written that it's an upgrade of what we've been doing, and so I think it streamlines it a little bit and a little bit more simpler to write. The first page is always going to be your Wisconsin Standard Drawing number 1, and that's what typical in all of our plans and deliverables that we do. And then here's the sections that we have, and we'll go over each one. So here's our cover page and how it looks. And we want to put the landowner, and the practice is always CPS 449 Irrigation Water Management Plan. We have, if you're coupling this with other practices, I think we have been debating and talking about it, and I think our best approach is to keep the 449 its own document. So the recommendation here is to not mix it into your construction plans if you're doing a pipeline, for instance, or a center pivot. The idea is the construction is construction. That's a different animal. The irrigation water management plan is a plan for implementation. They're different phases of the same project. Construction is installing the irrigation systems, which Dr. Wang talked about, making things better, but then the scheduling part is the 449. I hope that's clear. So I think you all understand how these work, and we put the project location and all the landowner information. I put down here for approval is the job approval authority class, and it's based on the size, acres. And so if you, and this is based on how much irrigated acres you are scheduling in that. And so we've had a guy that had 8 pivots and it's over 320 acres. That's a class 4 or above. But if you're doing a smaller system, it's a class 1 if it's under 40 acres. I hope that's ask any questions if you have one there. So the irrigation water management plan, the first sheet that we talk about is the objective, and we really don't have to change what's here. Both Beth and Dr. Wang's presentations talked about what scheduling is the process of determining and controlling the volume, frequency, and application rate of irrigation water. This is straight out of our standard, and I don't think we need to change it. We can add to it, you know, based on what a grower, he or she may have some more objectives they would want to look at, and that's something we could add to. I do list the resource concerns, and that's in the template. And so you could just check off the boxes on what you need. So these are already in there, so you don't have to go and write them all down. The template will have them, and these, instead of these little dots here, I got boxes, so you can just check them off on what we're working, what our resource concern is. And then here is where you have to do a little bit of writing in the plan summary. There's nothing in the template. You've got to go in and kind of write down a detail. And so I got some things that you would put in the plan summary. And that's just to summarize the system layout. And we need to include a map. We need to talk about the crop rotation and the soils and how irrigation is going to be scheduled. It's just kind of a summary. The next section is the system information and evaluation. And here we want to put each field that's going to be scheduled. So, and we want to put the irrigation type. And so like field 1 has a center pivot. Field 2 has a micro irrigation. Field 3 has a lateral move sprinkler system. I want to emphasize that scheduling can be done on any type of irrigation. In that it doesn't have to be a center pivot. It could be on any type of irrigation that we do. It means that they're treated a little bit different, and we had to recognize that in our irrigation plan. Here we have the total irrigated area, and we have in the template some ideas how to calculate that. And if you have problems of trying to figure out how to do that, please call for help and talk to your area engineer or call the state office, and we'd be glad to help you. The length is the length of sprinklers or the length of the drip system in that, or the length of the pivot. The lateral spacings is spacings between sprinklers. If you have a center pivot system, that's not applicable. And you'll see that these headings aren't applicable for some of the systems, and they're just there. This just helps us explain the irrigation system, and it kind of meets that first part that Dr. Wang talked about irrigation systems. We want to know where the water source comes from. We want to know where the pump comes from. It's not really pertinent to scheduling, but it helps us understand how things are going to operate. Beth talked about maybe a well does not have the capacity, so they do strange things, and that's a management thing they have to deal with. And so our plan has to reflect that. We want to know where power's coming from. There again, electric rates are different at different times. And again, that's part of the irrigation water management plan that we need to be aware of. So we write it that something help the farmer put the best plan forward for them. And of course, flow is good and pressure is good, because pressure is actually what controls your uniformity on an irrigation system. If you have good pressure and all the emitters or sprinklers have the correct pressure, they're going to perform correctly. I could build you a great center pivot, but if I'm not operating at this right pressure, it's not going to do what I hope it does. The next section is how are we going to measure the inputs for irrigation scheduling? And so I put here, flow meter is the best method for measuring applied irrigation. A lot of your people are going to use sprinkler charts and pivot run hours. That's good, but it's not as accurate as a flow meter. If we're paying people to do a CPS 449, and we need to be serious about it. This is really a good recommendation, is to get them to do a flow meter. Everybody's going to be frowning about the cost. They cost $2,000, $3,000. But once you get it in, they're always going to be looking at it to see if their system works correctly. They're going to like it. It's just getting over that initial hurdle of the cost. But if we're paying for it, and I think we could give a strong recommendation. I know that Steve, our state engineer, he's looking at maybe a scenario where we can add the cost of doing a flow meter. That's something we're going to investigate for next year. Beth already talked about applied irrigation is always limited to either your readily available water, and that was, if you could refer to Dr. Wang's presentation, she talks about that, or your soil intake rate, and this is where you do runoff, and we got trainings on this, and it's in the references that talks about that. And again, Beth already talked about it. If there's fumigation or pesticide going through the pivot, then there needs to be a 590 and the 595, and that needs to be part of the plan. So those need to be meshed somehow. Then the next section of the template is crop information. And here for each field, I got field 1, we put the crop rotation down. It's important, even though we may only be contracting 1 or 2 or 3 years, the plan needs to reflect the total rotation that the producer is trying to do. The reason because of that is the rooting depth. The rooting depth, and also the MAD, the manageable allowable depletion. Each one of these change. If you see through field corn is 30, and then over here is 0.5, and then maybe after corn they do potatoes, there is a 16-inch rooting depth and a 0.35 MAD. If you look here, the readily available water, raw, and this is applied irrigation, it changes. So for field corn, we could put 2.25 inches, but for potatoes, our target becomes 0.86. And the idea is to not over irrigate, to do deep percolation on the crops. And so this is really important that we get this right. So an irrigation water management plan, depending on the year, depending on the crop, will have different targets of irrigation. And this is just a guide for the farmer on how much water should I put on based on the crop that I have. The next section is the soils information. So what we do here is we go into our soil web soil survey, and we download the map, and we just put it in here. And then what I did is I manually draw what the irrigated field is. You don't have to be too fancy on this. You can be, I'm not saying you can't, but don't spend a whole lot of time on this, getting this down with electronically. Just a hand sketch of the irrigation system and where you want a soil moisture probe is fine. It's just really information basis only. And then part of the soil information is we go to the web soil survey and we put in our field capacity for each rooting depth of our crop plans of our rotation. So here we got different managed root zone depths. So the first year, I think we had 30 inches, and the next year we had 16 inches on that example. And then we put field capacities here for each one. That way the farmer knows what his taw is. We also put the permanent wilting point, and the taw is calculated based off these two figures. Then we put these numbers into the irrigation water management plan template in this section, and you can see how this works. Okay. So the next section, we have to look at irrigation runoff potential. And there's a couple ways of doing that. One is in our references, we have table 11-5. And I will tell you, in Wisconsin, this is probably pretty good right here. And you could go off this. There's a ground slope here, and then the soil type, and you can see what kind of the application rate is. And this is sufficient for our needs. If you really want to get into it, you could use CP CP nozzle computer program. That's only for center pivots though. So if you're using like a big gun or something else, you got to come up here to table 11-5. Table 11-5 could be used for center pivots as well. It's not required you use CP nozzle. The reason why I say that is CP nozzle is not a user-friendly program in that. And so if you're a little squeamish about it and you're not confident about it, come to this table. If you want to try to use this, contact somebody who does know it, and because this is a useful program. But I just wanted to offer that both of these options are satisfactory. So then the last section, which I think is the most important about, is in irrigation scheduling information and documentation. What this means is how are we going to measure our inputs and how are we going to record them? And so we're going to look at weather forecasting, and these are all boxes you could check. You don't have to write it down. The idea is you could use a local weather forecast or an internet weather site. The next one is determine precipitation, and Beth talked about that. We could do in-field rain gauges, on-farm weather station, or local rainfall data. You got to be careful with local rainfall data. It's got to be really close. There has to be a weather station close to the field to be really applicable. And so what we want to do is recommend either the on-farm weather station or the in-field rain gauge. We want to determine applied irrigation depth. This is critical. We could also do an in-field rain gauge if they don't want to use a flow meter. We got the manufacturer sprinkle nozzle chart or an emitter chart. But I want to really push, we want to recommend flow meter. There's no better substitute than a flow meter in that. If they want to be serious about what they're doing, flow meters are required. So determine soil moisture. We could either do the soil moisture sensor or we could do what I call the checkbook method, the Wisconsin Irrigation Scheduling Program WISP or the spreadsheet WIS in that. Those are our options there. And so in Dr. Wing's presentation, she talked about soil moisture sensors, and she also talked about the ET. When I say ET, this is the checkbook method in that. And what I don't have listed here is that the temperature canopy system and other technologies that might be there. We need to be aware of them, and I appreciate her bringing those out. Then how do we determine when and how much to irrigate? We could either use a paper copy of the checkbook moisture balance. Using Crop ET. We could use the computerized checkbook scheduling software or spreadsheet using Crop ET. I don't have that in here. I should have. Or we could use the soil moisture sensor and then our MAD to determine that. And then the last thing is how are we going to report on irrigation scheduling? So we could print out the outputs of these spreadsheets. We could print out a report of the soil moisture software or a consultant report. All are required, but they have to, and we'll talk about it later, some of the requirements that we need on the report. Additional recommendations that we could put in, we could tailor instructions for the site, and please use the other considerations in the standards. Go through those and see what is applicable for the site and put those in. The stuff that Beth went over. And then it'd be good to put these references into your irrigation water management plan so your farmer has an idea where to go. Our timeline for doing this, people are always asking, how do we do this? Well, we have our initial meeting with the landowner to discuss the practice and look over their thing, and then we'll go back to our office and we'll write the plan. Then the next thing is to review the plan with the landowner and get their idea if they like it, and if they do, then you could go on to their, they could put an application in and do the contracting and go from there. If they're awarded, and you got to do a 449 with them. The first year is an implementation year, and so we put in any soil moistures, we field review the implementation, and we discuss the upcoming season record keeping. At the end of the first year, we want to review the first year's season. We want to actually have a sit down with them and talk to them about what they learned and what. Then the more important thing is what will you do better in the next year, and so discuss the next year how they're going to do their scheduling. And they call it record keeping because that's what we're looking at. It's all about data management. And so it's about measuring data and about keeping data. And so the next year is the same thing. We review the previous year and then we talk about the upcoming year. And so this just kind of gives you an idea of how to implement the 449 with an applicant. In the review of the scheduling records, they will present us this, and I want to emphasize here, we should never be in the business of telling the producer on when and how much to irrigate. We are not consultants. We should refer to the producer to the data and let the data drive their decisions. This means that our role is to be technical advisors on interpreting the data and explaining what the data is saying so that the producer gets to know. They make their decisions based on their own issues. And Beth talked a little bit about that. You know, there may be pumping issues, there may be other management issues that they're dealing with and so, you know, I look at this one, I go, what is this guy doing down here? You know, why is he in this area? He should be in these bumper pads right here in that. And we could talk about to the landowner, well, what happened here? And there's a reason why they're down there. And they could say, well, you know, I overslept and I stopped doing the program and this is what happened. And I lost my crop, you know, or I was harvesting or something like that. There's reasons behind it. And so our question is to ask, how? What are you thinking? Why did you do that? What did you learn from that? Those are the questions we want to be doing in that. And so we discuss it. And the other thing is to calibrate your soil moisture. Just because you put it in doesn't mean that it accurately reflects what's happening. You got to kind of use the data to see if it's working right. It's based on soil type. It's based on how things work, the depths and stuff like that. This stuff has to be calibrated. All models have to be. And so the first year is about calibrating your soil, all your measurements, and making sure that they all make sense. And so that's why we like to contract for 1 or 2 or 3 years, is because by the time we get to the 3 years, hopefully we get all the bugs worked out of the system so that this program is useful to them. Things to consider is their willingness to use technology, their preference on using a consultant, data availability, their time for obtaining and entering data, and oftentimes they just need help setting up the program. I call it a data management system because that's really what you're doing when you're doing scheduling. In my experience, producers appreciate data. And so our selling of the irrigation scheduling is, hey, let's get good data and let's look at available data and how do we look at it. CPS 449, that's really the goal, even though we talk about how to irrigate and when to irrigate, but it's really about using that data, organizing that data to make those decisions. That's what we're really trying to do. That's the rubber hitting the road right there. 449 will pay producers to do a job they already are partially doing. Everybody's out feeling the soil. They're all looking at the weather. To me, 449 is a great benefit. You don't often get paid to do a job you're supposed to be doing, and 449 does that. It's even better than a new center pivot because it's something that there is no economic life on the 449. This is a life-changing thing. You're introducing management, making people better at doing what they're doing. Center pivots rust, they fall down, then you have to replace it again. This institutional knowledge will stay forever. The benefits are far outlast any irrigation system. And so for cranberries, what do? This is a little different thing, and the university again has a place where you could get information from, and then you can see it right here. You got a link right here, and I'll pass these slides off later this week to you guys. And so what you're looking at with cranberries, they do not overhead sprinkler irrigate or drip irrigate. They irrigate from the bottom up. And so you got to look at drainage and irrigation, and you're looking at a water table. And then you're also looking at the 6-inch or 12-inch bed of the cranberries, whether it's too wet or too dry. So cranberries are a little bit complicated. Because they need both water sources, the groundwater or the water table that you control with the drainage plan or a surface irrigation plan, and then the sprinkler systems that irrigate from the top. And so this guide kind of gives you an idea where they should be on their systems. And what we want to do here is the reporting system's different for cranberries, because we want to talk about water table. We want to talk about the soil moisture. They usually use tensiometers. We want to look at the canopy temperature, because the sprinkler system is used for frost protection and it's used for cooling, but it's all applied water and it's all should be part of water management. And so what the idea here is to collect data on what they're doing so they could start understanding how things work. And then this allows them to tailor their management for future operations on stuff. They could see when does the temperature stop and when should they turn on things. And they already know this, but they don't really have it written down. And so usually the guy in charge, if he's gone, nobody's there to replace that management and that to make decisions. And so the idea here is to have them start making getting the data so they could irrigate that. So with that, any questions?
I've got a couple in the chat as well as coming into me personally. One question was, what are your thoughts on sensors for cranberries in organic soil and sand soil? I'll just pipe in with a little history. I know we've always had concerns with the sandier soils of having a sensor actually act appropriately and give accurate information. I don't know what your background with those are, Mike.
So cranberry growers use them. They believe them, and the reason why is because those organic soils don't have any water holding capacity, so they have to know right away when it's drying up. And they tend to only irrigate one hour a day. They don't put a lot of water on, but they need to know when it's getting dried. And so soil moisture sensors, I think most cranberry growers will say, is a must. And that's based on the experience that I've seen. Yeah, they don't put them vertically in the tensiometer. What they do is they put them at an angle because their profile is so small. It's only like 6 to 12 inches.
One thing that I have seen is it may not give you an accurate number, but they're going to see it registered. They're going to see something change.
Correct. And they're trying to be rough in their approach. They want to know whether it's wet or dry. That's really what they're looking at. And they go from, like, on a tensiometer, I think 3 pascals to 7. And they just bounce it between those two things.
Okay. Another question, if an operator is not a technological user and is unable to implement the 449, can we still contract a new irrigation system with them?
They need to Beth, you
go
can
ahead. Go ahead.
Well, in my opinion, they need to still contract the 449, and somehow they have to figure out how to do data. They don't need to have a computer to do this. They could do it with a paper. And so it may just be printing out a thing. And all you have to do is go read your measurements and write it down in that. And they won't have the plot, you know, that Dr. Wang's showing the field capacity and in the MAD point. They won't have a plot by that, but if they write down the data and they start looking at it, that's what we're really training them to do. So yes, we need them to get a 449 somehow in and implement. Now I hear from the field, well, this puts the burden on me because now I have to babysit them. It's a lot of time and effort, and maybe Beth, you could address that.
It's some of it is babysitting, but I don't think the burden totally comes onto you. I mean, you don't have to do everything in technology. I think technology makes it a heck of a lot easier, and you can show that to them. But there are landowners who that's just not for them. I have seen a landowner not being willing to do it, but a child or a spouse or someone able to take care of the technology side, and they still do use WISP even though they themselves are not comfortable with it. 1 second.
Any other questions?
So I'm getting comments in on my own teams, so give me a moment. I've got one comment here that they're working with this in Marathon County and they flopped with the computer last year, so they're going to try the paper method this year. So it is something that you're going to need to be at least aware of with your landowners.
Yeah, and that's good. That talks about what worked last season, and well, if that didn't work, let's try it this way.
Yep. Here's another one. When we used on the other template, there was a question regarding the system uniformity. And on the new systems, the uniformity was provided in the sprinkler package so that it was easy. Agreed. It's a lot easier to go with the sprinkler package. But how old is too old to not trust that manufacturer's value? 5 years, 10 years, 20 years? If we recommend a uniformity test like the catch can test, who does those tests? And is the cost cut into the payment for IWMP? Lots of questions in there.
Yes, and I will try to attempt to address it. And Beth, you may have to correct me. So we do irrigation systems is an important component of irrigation scheduling, but I want to emphasize that they're separate items. Dr. Wang actually brought up a great point, and I'm glad the way she presented it. She presented them as parallel tracks, and so you have to think about them. They could operate independently of each other. However, they're better off if they're put together. So with that said, a 449 is about behavior. It's about management. So a 449 can operate independent of the irrigation system. So it doesn't matter what type of an irrigation system you have. The 449, you can have a bad system, and your 449, they'll be doing this and they'll say, you know, I'm irrigating that dry spot and it's not working out and I get all this deep percolation. Well, in your interview, then you could say, well, obviously you got a uniformity problem. And so then let's see what's happening to uniformity. Well, how do I do that? Well, you do a catch can test. Well, can you do that for me? Well, yeah, we can do it. Or you could call the irrigation dealer and they'll come out and do it. And then they'll be able to tell you what to do with your system. So what I want to say here is the 449 could be a catalyst for doing irrigation system upgrades in that. The data will tell you what you need to do. On the other hand, when we're talking about irrigation systems, we're putting a brand new shiny pivot on somebody's field. We just spent $70,000 there. And if it's somebody like me, you know, I don't need data. I just go run the pivot when I want it to. It doesn't matter then. If I put a nice shiny system and I run it 24 hours, 7 days a week, I'm not doing good management and I'm just wasting energy and water. And it doesn't matter what kind of a system I have in that. And so that's why the 449 has to be with the irrigation system in that, because you get a shiny pivot. If you don't know how to operate it, then it does no one any good. But on contrary, on the other side, 449, you could run a bad pivot as best as you can with good management. And so a 449 can be independent. A system does need a 449. A 449 doesn't need a system. So uniformity, to me, is not something you have to really go look at the beginning of the job. It's nice to see what's out there and give recommendations, because that's going to come down the road as you talk about, you know, their management, because those things will come up on how to improve irrigation. Did I answer that all right? Okay.
I was gonna say, it's just, there's a lot of questions when it comes into those catch can tests and that uniformity test.
Yeah, there is. And what I don't want to do is waste our time on a 449 doing catch can tests, because they are very they require a lot of effort. Where we do a catch can test is when we're evaluating a system, and it's when they're looking at replacing a system. I guess maybe that's the best way to answer. To me, it's a time how do we allocate our resources in helping people?
I think the question comes down to is we wanted to make sure that if we were going to do an IWMP, we wanted to have some knowledge that the uniformity was going to be reasonable on that system. You could tell them to run it at a perfect rate, but if the uniformity is really screwed up, you're not going to get what you think you're getting if you fall back to the manufacturer's uniformity and that system's old enough that you're not getting that anymore.
That's correct, but I think the data will lead you to that conclusion. And the idea is for them to discover that, because they may not want to buy a pivot right now, but they want to do some management. And so the idea is to incrementally get them to where they're willing to invest into a new system upgrade.
Yeah, this one, they said they were talking, the system they were looking at had soil moisture sensors is what the landowner wanted, and that triggered needing an IWMP. And for those old systems over the 15-year mark, you know, if they're not giving you, again, the uniformity that the manufacturer had originally intended at the beginning of its life.
That's correct. And so you got to look at placement of that soil moisture sensor in a representative part of the irrigation system.
The other question came in is when you use the chemical or fertigation, can we pay for an IWMP without a 590 or a 595 plan? And I was pulling up the 22 cookbook, and I'm not seeing 590 and 595 referenced. Again, someone type in if I'm missing something on quick glance. But my gut is that if you have an IWMP that is written for how it's going to be operated, you would have to have that 590 and 595 plan included or come alongside it. Otherwise, until that's out there, that 595 and 590 are part of the operational plans, you're not going to have an accurate IWMP.
Very good. We're going to have to move this along, and so I'm open to other questions outside the session. You could call me, or I'll try to reply to the chats if we haven't talked about this. But Dr. Wing, are you there for your next presentation?
Yes.
Okay, I stop sharing my screen so you could share your screen again.
Okay. You see it?
Yes, I do.
Good. Okay, so I think I don't need much time. This talk is just to quickly go over some of the most common soil moisture sensors available right now to the agricultural industry. I mean, we covered soil moisture a lot today's session. So it's a good way of understanding how much available water in the soil in order to respond to the crop water need. So I talk about this hand feel method. So let's just skip that. It's just kind of like an experience-based information that never gives us any accuracy. So we gotta, if we want to quantify the available soil moisture, we have to use some sensors. The first one is tensiometer. This one measures the soil water tension, meaning how much tension, we're measuring how much tension is needed in order to extract water from the soil. And so it's an indication of water extraction rate. It looks like a mechanical root in the soil profile. The readings are in centimeters of vacuum. And usually if the soil is not too dry, the readings will be accurate. So the kind of a rule of thumb is up to 85 centibars. centibars, it will be accurate, but anything higher than the 85 centibars, it will not be accurate. So it's only installed during the growing season next to the rooting zone. So, and Mike talked about install it with an angle, so it kind of measure a more larger space within the root or within the soil profile. Maintenance is really required, especially to refill the water on the top of the tensiometer. Some people will add some color agent in order to kind of read the level of the water more clearly. There are different lengths of this tensiometer depending on your need, how deep you want to install in the soil. Usually it's very cheap, but my experience with tensiometers are that it just gives us a reference. It's not consistent. It's really hard for maintenance, especially like refill the water. Sometimes just water goes away really fast, and you need to keep an eye on that. So maintenance is a big issue for using the tensiometers. So I'm not a big fan of this, just to be honest. But my lab has used a solar panel supported data logger connected with the tensiometer, and we kept reading the numbers like consistently over the course of like 3 weeks. I think that way is much better than kind of leaving the tensiometers in the field and just once in a while visit it. I don't think that's quite as informative. So interpreting the soil tensiometer readings, there are some kind of quick facts. 0 to 10 centibars, it means there's saturated soil. It's above the field capacity. It's really wet. 10 to 20 centibars is at close to field capacity. 30 to 60 is a usual range to start irrigation for sandy soil, like in central sands. I would say 40 centibars is a good number to start thinking about irrigation. 70 to 100 centibars for the heavier soils. It needs to start irrigation. And especially for like the clay soil, in the water tension needs to go up before like completely. The soil needs to dry up more completely before you start irrigation again, just to avoid the over waterlogging issue. And then anything above 100 centibars is going to be too dry. And here are some numbers here. 1 centibar is equivalent to 0.145 psi. So just to keep in mind, the higher the readings from the tensiometers are, the drier the soil is. So here's a graph indicating the centibars of soil tension versus how much water available in the soil profile. These 3 curves here indicate the water curve for different soil types, and we can see for sandy soil, it needs less tension to extract water from the soil, and for the silty clay soil, it needs more tension to extract water. And so for 50% available water, sandy soil has lower centibars, numbers of centibars, about 40 centibars for about 50% available water. So if the tensiometers shows the reading 40 centibars on in the sandy soil, it definitely means that irrigation needs to be started. Otherwise, it will reach to the permanent wilting point pretty fast. The next type is called the electrical resistance blocks, or the watermark blocks. This one measures the electrical resistance when the water moves in and out of the blocks. it needs to have really good contact with the soil in order to have accurate readings. Cost is low. Per sensor is about $40. And then the data logger or the meter to read the sensor is about $300 each. This electrical resistance blocks are very sensitive to temperature. If it's too high or too low, the readings will not be accurate. And also, they're sensitive to high saline or acid soils. So it has limitations, but it can withstand some freezing environment. It can be reused for maybe a couple of years, but I would say more than 2 to 3 years, they are done. So not very durable. The next type is called the time domain reflectivity or TDR sensor. It measures the relative permittivity of the soils. The idea of TDR is actually from the technology that was used to find bricks for the phone cables underground. They have two types of TDR, either hand probe or buried sensor. The hand probe will be a little more, a little cheaper than the buried ones. It can read directly the percent, how much water in the soil in percent. And then cost depends on the type of the TDR sensor. It can vary between $200 to $1,200 per sensor. Just based on my experience, so far, my favorite is TDR because it's more consistent, more durable, and it just gives us less trouble during the growing season when we're working on the inessential sands. The next type is capacitance sensor. It's directly measure the volumetric water content, relatively accurate, about 3% below or above. So for all mineral soils. So this one is universal. Cost per sensor is about $100. For a 5-channel data logger, it's about $400. This one is more stable under some more extreme environment like saline or extreme temperatures for the soil, and can be left in the soil over the winter. But I should say that for all the soil moisture sensors, if there are cables, the best way of storing them is just to remove them before harvest. So I've have many students who installed soil moisture sensors in the field, in the commercial fields, and for on-farm trials, just because of some miscommunication. The cables were just shredded during operation, and it was really frustrating. So storage and maintenance are always a concern for moisture sensors. A good tip that I learned over the years is that soil moisture sensors can be installed on PVC pipes, and then you can insert those PVC pipes in the field. With the moisture sensors attached. This way, you can insert to different depths of the soil and at different locations. So this is an easy and cheap way of installing the moisture sensor. A more sophisticated system is multi-depth stationary system. They have, a one stick, kind of like a stationary stick that you can insert into the soil profile, but at different depth, there are sensors that can tell the moisture level of the soil. And then this system can upload the data in real time. So everything is going to be cloud-based. You can remotely have remote access to the data via a smartphone or tablets. So very easy for remote management. Because of the accuracy of the system, usually it will be linked with VRI software, and obviously it will be way more costly. So per system is going to be $2,500 and up. If we divide the different types of soil moisture sensors by their configuration, we have this portable handheld probes like the capacitance or TDR. They're very easy to carry around, can cover a lot of area if you kind of walk over the field. But if you want to measure like different depth of the soil, it might be a little more difficult. Sometimes you have to dig a hole for those handheld probes. For the in-place sensors like the tensiometers and reflectance blocks, well, obviously we also have the in-place capacitance and TDR. For those in-place sensors, it's good to monitor in different locations and different depths. If you have that resource to buy different sets of sensors. But I should say that, again, the biggest limitation of soil moisture sensor is that it's really site specific. Only one spot or a couple of spots within one field can be installed with the sensor. So we just cannot tell the spatial variability of the whole field. That's just the limitation of the soil moisture sensor system. For the data logger, usually it will, the data logger most of the time is needed, and the cost will be different depending on how much channel, how much portals it has. It can read numbers every 15 minutes to 1 hour. And the price can be from $300 to $2,000. So obviously, the more expensive, the more channels it can have. One experience I learned is that sometimes a data logger can have multiple channels or multiple portals for different sensors, not just the moisture sensor, but also like the temperature sensor or even the rain gauge. But obviously, if it's more sophisticated, it's going to be higher cost. So the last system I want to mention here is a kind of a more comprehensive system, and I've seen that being used more and more nowadays among the vegetable growers because it's high value crops. This system incorporates all sensors into one central hub as kind of like a remote system. So they will connect the rain gauge, the moisture sensor, the soil temperature sensors, everything into one kind of central data logger or system, and this system will read it, and then it will incorporate the weather forecasting and run some machine learning algorithms to tell the growers, just based on all the factors it's measuring, and to tell the growers how much water to be applied. Kind of like a more precision agriculture standpoint. From a precision agriculture standpoint, this one is more cutting edge and more innovative. It needs a lot of cutting edge technologies, and so it's just more efficient to some extent. But the downside of this kind of complete system is that I heard of some feedback from the growers who has tried this new system. The most common complaint is that different companies will have different systems and they're not talking to each other. And then the company that's making the systems are having different kind of versions depending on what irrigation system the growers have. So if there's just no way to incorporate data from different systems into a consistent, like a universal data set or a central system. It's just different schedules or different systems have different readings, and it's just very hard to talk to each other if they're using one version from company A or using another version from company B. So it's very complicated. And there are very large competitions between those private companies, and sometimes it's confusing. So I just don't know how to address that. I am bringing it up to the table, and just so you folks are aware of the situation. We do have the technology, but it's not, people are not talking to each other at this point. So just a summary, soil moisture management technologies, we have kind of this from the simple level to the high level. Simple level is hand feel, or using some of the more simple moisture sensors like the mechanical tensiometer, watermark blocks, or TDR capacitance. And the highest level is to have this multi-sensor system with telemetry. So it's kind of more comprehensive. If especially for those large farms that have more resources to spend. So we have this UW Extension irrigation publication that's available online, and the title is Methods to Monitor Soil Moisture. It's published by my colleagues John Tomuska and Scott Sanford. Both of them have retired, and so that's why I'm here today. So if you need access to this or any other questions, just let me know. So that's all I have here.
Thank you, Dr. Wang. We got those publications in the chat if you look up there. Any questions for Dr. Wang? We have reached our 11 o'clock time, and I talked too long on my session, so I apologize. If you need to jump off, that will be fine. I will continue doing the next two presentations, which will take 30 minutes. The recording will be there, so if you want to come back and look at them, you're more than welcome to do that. But I'll try to finish the training so that it's in the recording, and I understand if you need to drop off. And so the next section, let me see here. Yeah, it's this one. I'm going to quickly go through it. It's the irrigation scheduling program in the spreadsheet. This is the implementation part of the 449. And so we'll talk about the references. Here's the agenda. Talk about the checkbook method and water balances. And then both of those, the WISP and the WIS, and using soil moisture sensors in them. What does a producer need to know in conclusion? After this, we'll talk a little bit about hoop houses. And so we already talked about this reference, and this is in the chat line. And so what is the checkbook method? It's really a water balance of the root zone. And so in our references, we have this figure 2.1 that shows you all the inputs of water coming into this area. So in engineering, we always do a free body diagram, and that's exactly what we're doing here. And then all we're doing is accounting. And we call it the checkbook method because it's very much like your checking account. And all you're looking at is this change of storage, and in your checking account is the change of how much you have. And you do this on a daily basis, and your bank account goes up and down based on your credits and debits. And this is how you manage your money. And if you can manage your checkbook and always keep money in there, you're going to be a happy person. But if you deplete your checking account, then you're not very happy. And it's the same thing here that we're doing. And so this is the equation that is used for the checkbook method. And this is in our reference. And there's a lot of stuff here. I won't go through each one. But so the water balance that we are doing when we're doing the checkbook method is we get our evaporation from the University of Wisconsin. They have an evaporation model using the Taylor-Priestley method for the whole state. It's really nice, and they email you the data. We measure the rainfall, the precipitation, with our rain gauge or our weather station. We measure the applied irrigation, I'm hoping with the flow meter. That's what we're doing there. If we have a good system and we limit applied irrigation to be below the soil intake rate, then we eliminate runoff. So we could cross this out of our bounds. We also, if we have good drainage, we eliminate upward flow. This is not true for cranberries, but in most crops it is true, so we can eliminate it. So what happens is the equation actually closes on soil moisture storage, the change in soil moisture storage in that. And deep percolation, it only happens when the soil moisture reservoir, or when our storage exceeds the field capacity of the soil in the root zone, then we have deep percolation. So if we could keep the soil moisture underneath the field capacity, we can eliminate this. And so all we're doing is, this whole thing is to figure out what is happening here in the soil water storage. And so we have tools to do this. And what I want to emphasize is there is more methods here than what I'm going to demonstrate. And we're going to demonstrate the WISP and the WIS. There's other software packages. There's consultants. You can do it by a paper record. And our job is just to provide technical advice to the producer and help them select the tool that is best for them. And so if they come with a crop consultant, 449 is okay with that. And so we just have to tell them what we require in the reporting and be okay and let them go their way. Things to consider is all of these tools require that we measure precipitation and applied irrigation. They also require measuring or estimating evapotranspiration. When we get our evaporation data from the University of Wisconsin, we are estimating that. There are instruments you can get that measures evaporation, but they're costly, they're hard to deal with. And so I'd say for the most part, we'll be estimating evapotranspiration. The checkbook method may be used without a soil moisture sensor, but the calculations will not be as accurate. We do want to recommend soil moisture sensors. If you're steering a farmer, steer them towards a soil moisture sensor. They may say, I don't want to do that. We could still work with them, but let's recommend them. The reason why is because soil moisture sensors help calibrate the water balance that we're doing. Remember, we are estimating evapotranspiration. We also might have errors in our precipitation measurements and stuff like that. There's always all this little uncertainty, and so a good working soil moisture sensor will bring us all back to the truth. It will, but I don't want to say they're not a standalone tool. You can't just put a soil moisture sensor and expect it, well, this is accurate. They require calibration, and in order to calibrate them, you need to collect data. And so your first year of operating a soil moisture sensor, I think you need to kind of ground truth it by collecting all the other data and do the soil moisture water balance to see how it works. And over time, I think it could become a standalone tool. And Dr. Wang, if you're still on, I don't know if you could collaborate that or not, but I think that's just based on my experience is what that's why I put it down here. And so the key of all this is to use data to make irrigation decisions. And when we make decisions based on data, the benefits is we'll reduce energy, we'll save money, we'll improve yield and quality in that. Oftentimes people say, well, I know what I'm doing. Well, I say that all the time, and then they start collecting data on me and I realize I don't know what I could do a lot better. And that's the idea here. And so I'm going to go first over the WISP. It's one of our many options. And you could get to the WISP by doing this. And it stands for the Wisconsin Irrigation Scheduling Program. It's a web-based program put on by the university. And so you come up here and you go click on the sign up, sign in, and your job is to help the owner, the producer, if they choose to do it this way, is to help them get set up. And the first thing when they do is get this set up, they have to enter in and get an account set up, and that's just putting their name and their passwords and stuff like that. One thing I do want to mention is that usually one account is for one farm. You don't need an account for each field because the WISP will handle multiple farms and fields. So you may have a grower that owns 2,000 acres over 6 farms and 6 different locations. They could have one account and then have manage all their fields from this software. And so that's really powerful here. You can consolidate fields into field groups, which means you could put in only one precipitation event. Otherwise, you always have to input all this data. But if it rained 1 inch all throughout Wisconsin, you could put 1 inch and it will populate all the fields. The other thing about WISP, it has forecasting ability in that. And so it allows you to kind of look forward a little bit to help you make decisions. And that's a real nice thing about WISP. This is the screen when you come to data entry, and the field inputs are the name, area, soil type, field capacity, permanent wilting point, and target allowable depletion. I think these calculate by itself. I'm not exactly sure. We just have to play with it. Then there's an area for crop inputs, and it's the same thing that comes from our irrigation water management plan. All the stuff that you compile in there will go into the spreadsheet. And then each day there's daily data inputs that will be in there. The nice thing about WISP is if you sign up for the university's service for a given ET, it will self-populate, so you don't have to populate them in that. But you do have to enter the rainfall, irrigation, canopy cover, and soil moisture sensor. We'll talk about canopy cover just a little bit later. The reporting of WISP looks like this. This is the output that you will see. And it's kind of graphical, but it's only limited to 9 days. And so you can see I got my soil moisture here, 9 days, and here's my field capacity line. This green line is my MAD line. So I'm trying to keep it over here. And this red line is my wilting point. And so you can see they're operating kind of low right here. And so what you want to do is try to irrigate in this area, I think. That's the idea in that. This is not sufficient, however, for our 449. And so WISP does allow for you to export a CSV format if you look over here. And then they're going to have to export that and give you that information so you have the entire season's record. And then they're going to have to hand put when they irrigated and stuff like that. I think it may show that because there's a place you put in here for irrigation. So then you can see what the irrigation was on there. So now this is the WISP. This is the irrigation scheduling tool, the Excel, and you could get this from the university as well. And our website has a link to this site, so you could get the spreadsheet here. It works the same way as the WISP. It does the same thing. It's just a different format. The WISP is, you got to have one spreadsheet for each field. And what we did there is each tab of the spreadsheet has for multiple years. This way you could keep a record for that field in that. We do the same thing for WISP as we do for WISP, same data entry. And so I'm going to show you a little bit about the soil entry. The first page of the spreadsheet, we have to go to the web soil survey, and we have to enter into the field capacity for these managed root zone depths and the permanent wilt points. And this is all in your irrigation water management plan. And so this is just a matter of putting everything in here from your plan into your implementation. We put our soil mapping unit down here in your coordinates so you know where to get your ET data from. You can obtain soil data from the web soil survey. After you select your area of interest, which I'm not going into, you come here to the Soil Data Explorer, then the soil properties and qualities. And if you look down here, you could see created the KSAT, which goes in your irrigation water management plan. and then also your water content, your 15 bar. This comes up here, you got your weighted average, and you go from 0 to 24 inch. This is your rooting depth right here. And then you push view rating, and your information will come out for that soil type. Some people ask, well, what kind of soil type do I use? And what I would say is use the most dominant type in the field, or the one that they will be irrigating to, which usually is the one with the least holding capacity. So then in the WIS, the next page is to enter your crop input. And so here we just put our plant date when we start. We select our crop over here. And what will happen is the crop manager root depth will come here, and then the MAD will come here. It calculates your raw. This is your target irrigation. Of course, this is on your irrigation water management plan, so you got to compare this with your intake rate to make sure you're not going to have erosion in that. You can override all of this in order to get the raw where you need it to be in that. There's various crops already in place in there, and the same thing I think in the West. And they self-populate the rooting depths, the root depths, and the MADs based on the publication that the University of Wisconsin has made. We can override a rooting depth. Maybe I'm a grower and I don't like that rooting depth. I could put another thing in here, and the same with the MAD, and that allows us to calculate the raw and do a new target irrigation. Our daily data entry page looks like this. And here we enter in our ET data. That is obtained from AgWX. It's a daily email from the University of, and here we enter our rainfall or precipitation from our rain gauge or weather station. Here we input our daily irrigation. And this is, we have to figure this out, usually from a sprinkler chart or the flow divided by the irrigated area. Here we input the plant canopy cover. The way the university calculates ET is they take this ET value and they multiply it by the plant canopy cover, and then they come up with a daily crop ET. These are the water bounce right here. Here's where we could put in observed soil moisture. When you put a number in here, it automatically changes this. So any entry here will change this value in that. And really, when you start doing that, you can start back calculating your ET to see how close you are. People are saying that the university's ETs over exaggerates a little bit. I've been playing around with it. I do think that's true. There's different reasons for it. Some of it maybe the way you characterize your soil moisture reservoir. There's a lot of uncertainties, and so a lot of calibration that goes on here as you're playing with data. The email from the university looks like this. They will send this to you every day. And so if you miss an email, don't worry, because you got 7 days of data that's there, and it's based on your location. It comes at 7 in the morning. So while you're drinking your coffee, you could go ahead and put your ET values in, and everybody's happy. To determine canopy cover, this is how you do it. You got your row crops like this, and you have your canopy width, and you have your spacing between the canopy width, and so the percentage here in this case would be 18 inches divided by 36 inches, which equals 50%. So that's what you would put in the canopy cover for the field. And of course, by the time you get to full canopy, it's just 100%. You don't have to measure this anymore. There's a tool that you can put on your smartphone that you can go out in the field and take a picture of this, and it will tell you what your canopy cover is in that. And so this is a nice tool to have. So in the reporting for WIS, we have this chart here that plots your seasonal amount. This, and what you have to do once you get this, well, this is what it looks like. So soil moisture sensors, we already talked a bit about that. And so that's just what that looks like. And you can read it from here and then go put it into your WIS or your WIS. And once you do that, it kind of self-calibrates everything. So what does a producer need? They need an irrigation water management plan. If they're going to use these tools for keeping track of their data and reporting, then they need a spreadsheet or an alternative tool, but they need some sort of tool to keep track of their data. They need a method for receiving the ET method. They need precipitation data. They need to figure out how applied irrigation is measured. They need to measure crop canopy. They need soil moisture sensor data. They need to know the reporting requirements, and they need the end of season interview. So here are the reporting requirements. You know, we could print out this page here. We could get the CSV file from WISP. A soil moisture probe looks like this. A consultant's report may give something like that. But what we really need is we need the season's record of the soil moisture reservoir. We need to have when irrigation is being done, and we need the amount in that. And so these are all really important for the report. This is how you look at data, because you could look here, I put 2.25 inches here, and I got my soil moisture up here, and then I bumped it 0.5 inches up here, and this thing bounced out, and I got deep percolation coming right there. And if you, I don't know if you can see it right there, that little line is deep percolation. So the question is, well, what happened here, you know? And they could add the same thing here. Same thing with the soil moisture sensor. We need to pencil in when they added irrigation. And when you see, the way you measure deep percolation is by putting a very deep soil moisture sensor, or you see a flat line here on the top. That means it's hit field capacity and it's gone over and there's deep percolation going on. So in conclusion of this, irrigation scheduling is about using data to make irrigation decisions. And all we're doing is the water balance of the soil reservoir. The WISP and the WIS are two options, and they're really good for managing data and reporting data. And so our growers like them. I don't really haven't heard too much about the WISP, but I know the people that use the WISP, they seem to like them. And whenever we do a contract, our producers need to know the requirements, because that will solve a lot of problems down the road as you're trying to, because you can't give them a payment unless they have a good report in that. And so any questions on that part? I got one more section, but any questions on the WISP or the WISP?
There are no questions in the chat currently.
Okay, I will move on. The next section is on hoop houses and small plots. This is the last one that we will go over. And the reason why we're going to go over this is because with our initiative into urban ag, I anticipate we are going to get a lot of hoop houses and small plots 449s. Some of you are already getting these, and the question is, what do we do with them? Well, the answer is we don't quite know yet. And so this is going to be a work in progress, but in the meantime, we do need to address how we deal with them. And so the answer here is the 449 for hoop houses and small gardens are more complicated than your larger pivots, because there's multiple crops, multiple growing seasons, limited water supply, increased management. The only thing they got that's simpler is they got usually a uniform soil in that. That's why Dr. Wang talked about using a portable soil moisture sensor going around the center pivot. It's because her soils are so variable, but in the hoop house, they're usually not. But hoop houses are complicated. And so how do you write a 449 there? The other thing is producers observe their plants on a daily basis. They know what's happening there. They know when their soil's dry and when it's wet in that. And so it's really hard to tell a producer will now start keeping track of it. Well, my answer to that is that's what a CPS 449 does. That's really the motivation here. It's the idea here is you need, if you start measuring and recording data, the idea is you can now quantify your knowledge. you could actually see how well you're doing. And it allows you at the end of the season to look back and see what could I have done different. It allows you to improve in that. And so that's really important, I think, in that. I will say the 449 for hoop houses, there's a lot of gray area. They're hard to contract. Questions on how many do we do? Do we do one for each hoop house or one for each bed? Those answers we're going to have to work out as we go. In the past, I think we tried to steer people away from it. With urban ag, I don't know if we're able to do that yet. That may be a policy thing that we come up with. But we could talk about that later. There's just a lot of gray area. But the idea here is I'm going to review the outside water bounds. We talked about evaporation, rainfall, and irrigation, how they measured earlier. And this is, it changes inside a hoop house. So inside a hoop house, we no longer have precipitation. So this is eliminated. We do have irrigation, which we need to measure. We don't have runoff unless you're not watching what you're doing, which they watch pretty close what they're doing. We don't have a drainage problem in that. But we do have evaporation, but you cannot measure evaporation. Well, I guess you could inside a hoop house, but you can't use the Wisconsin model inside a hoop house. And so the thing that you really can measure is the soil moisture. And so what I want to say is if we're doing 449 inside a hoop house, I don't think this is negotiable, in my opinion. I don't know how you do scheduling inside a hoop house without a soil moisture sensor in that, because the way the equation closes is it's on evapotranspiration. So you either buy a sensor here to measure evaporation in a hoop house, or you buy a sensor here to measure the soil water storage. Either way, somebody has to buy something. And that's just, I think, a reality of hoop houses. And that's what I would think would be a change. And so when somebody walks in your door and says, I'm going to do a 449 on my hoop house, you need to say, well, you need to buy a soil water moisture sensor. There's just no other way. I don't know how else to do it. And I've done a lot of research on this, looked at a lot of places, and there's really no magic bullet here. You can't just do it the other way like you can outside. Because outside we have ET models, and it's just based on how the equation works. And so our soil moisture sensors, we did talk about, there's two things when it comes to an irrigation water management plan. We need to understand soil moisture sensors is used to time irrigation, and then the amount of irrigation, of course, is limited to your raw or your soil intake rate. And that is determined by figuring out the volume of irrigation applied divided by the irrigated area in that. And so this becomes really important in a hoop house. And so we got to measure irrigated area. And so this is kind of a diagram for sprinklers. We have our bed 1 and our bed 2. And each area will be our width of the bed times the length of our bed. And so this is for drip irrigation. Drip irrigation is a little bit different in that you do have the bed the same width and length, but you only have a wetted area versus the dry area. And so that our references have a formula here in equation 7.8 that allows you to calculate the percent wetted area based on the emitter spacing, the strip of the area wetted, and you can get that from your emitter, your manufacturer, your plant spacing, and then your row spacing. And that allows you to calculate that. So we need to measure flow. And so, again, I recommend a flow meter, but flow meters may be overkill for hoop houses. And so the idea here is our emitters or our sprinklers usually have a discharge charge, but it's based on a pressure reading. And so if you look right here, if we have an operating pressure between 10 and 12 PSI, and I have a light green emitter, I get a flow rate of 0.8 gallons per hour. we can then multiply the number of emitters with the flow rate to get our flow. But what I want to say is at the beginning of the season, we ought to put a bucket underneath an emitter and measure it and see if that's actually accurate in that. And then we can have confidence that our flow is correct. And so there's different ways to do it, but I think at least one time during the season, somebody needs to measure to make sure that their emitters and their flow sprinklers are discharging correctly. So we have our example of how to do that of applied irrigation. It's the volume of applied irrigation divided by the irrigated area. So if I have a planter bed of 10 feet by 40 feet, the area is 400 square feet. If I have a flow meter that says 2 GPM, my irrigation duration is 1 hour. Here's the formula for doing that. That means I put on 16 cubic feet of water in an hour. And then I divide that by the irrigated area, and I get 0.48 inches. So in 1 hour, that sprinkler system puts a ½ inch out there. And that helps the grower understand how much you mesh this to your rod and see how long you need to do that for. For a drip system, it's essentially the same thing, but you have to go through that formula that I showed you, and suppose that it calculates out to 40%. Well, here on the irrigated area, you simply times it by 40%. And so instead of 400 square feet, it's 160 square feet. And so your applied irrigation looks like this. It's instead of 0.48 inches, it's 1.2 inches. This is a really robust drip system, but I wanted to compare apples to apples, so I kept it at 1 hour. Of course, the drip system would take a lot longer to do that. And so how do you use WIS in the hoop house? Well, can you? And the question is you can, except we need to change this column right here. There's a little formula change that needs to happen that basically allows you to have no entries over here. And the idea is you put your soil moisture sensor in here and it will keep track here. The other thing is your soil moisture sensor, you could keep track, on paper, and then they could turn that in, and so you can see what's happening. But the idea is that you get daily readings on your soil moisture sensor, and then you get daily readings on your applied irrigation. And that's what we're looking for. And so same reporting requirements, we definitely want to have some sort of history of the soil moisture sensor for the season. And then we want to put the irrigations down here that they put in there. And that's really what we're looking for from a hoop house. Things that we need to consider. We need to consider salinity management inside a hoop house. In that, outside of a hoop house in Wisconsin, you don't really have to because it rains so much here. But inside, when you eliminate the precipitation and all you're doing is putting your irrigation on, you are going to, if I go back up to this thing here, you can see right here, my salt is going to accumulate in these regions right here. And so our growers need to understand that they have to do salinity management here and keep track. And so that's one reason why a soil moisture sensor might be good, because there are options that do both soil moisture and also EC, electric conductivity, which will help you with your salinity, what's happening there. And if you do have salinity, then you got to put a lot of water on to leach it down. And we need to think about the sprinkler and emitter discharges depends on the pressure. And so pressure gauges at a hoop house, I think, are required so that everybody knows that everything's working right. Those discharges are meant to be that way. We got to look at our sprinkler spacing to make sure they meet the 442 standards in our drip irrigation. There's also ventilation to think about because that changes things. So I don't know if you put that on your report, but the grower may want to do that. Because that may change how much water they put on. If they're trying to build institutional knowledge, it may be a helpful thing for them to put on whether there was ventilation, if they had a window open or if they didn't. And the other thing is there's multiple growing seasons in the year. They may grow 3 crops of greens during a season. So you will see your you know, the question is, do you report on the whole season, or do you report on the growing season, you know, just for that 3 months that crop was there? I think that's a preference, and it just means more data to manage and that. And so I don't have an exact answer there, but you should consider it and figure out with the grower on how you want to manage that. And so small garden, what do we do here? They're outside, they're not in the hoop house. And
Mike?
that is, yeah, go ahead.
Before you continue, how often a year do you, or how many times do you have to flush the salts?
I would, you know, Doc Wing may have an answer there, but I would think once a year would be fine.
Okay. I don't
Usually
think she's on anymore. I've looked, I don't think she's on.
Usually out west, they do that, and they do it at the beginning of the season.
Okay.
They have a pre-irrigation, they call it a pre-irrigation before they plant. And that's when they do it. So in the garden, our water balance looks like this. It's the same thing as a big field in that. And so really it's the same scheduling a garden, and I scheduled my garden this year. I know Mary King did as well. It's the same as scheduling a pivot. You're doing an outside water balance. You're receiving your ET from the university. The only thing is you got to choose a representative crop. It's really hard to schedule a garden on all the crops unless you have different irrigation systems for each one. And then, so what you want to do is select the crop that's most important to you, I think, and irrigate based on that. You have to measure your irrigated area, and then you have to measure your flow. And that to me, I think is really important to understand what kind of flow you're getting. I don't think you need a flow meter, but you do need to measure the discharge at least once so you know what your system is doing. A pressure gauge there ensures consistency. Oftentimes, you know, people are wondering if I'm putting enough water on. And so if you have adequate pressure and you're putting on it for a certain period of time, you will know that you're putting on a 1/2 inch in that. And so to me, a pressure gauge, I think it would be comforting to know that I'm putting that amount of water on when I say I am. The other thing is I would recommend a soil moisture sensor, and that I think they'd be fun to play with in the garden. And so you can see what's happening, and you'll calibrate it, and that will for sure tell you what's going on. So that's how I would schedule a small garden. Again, there's not a lot of reference on it. I actually think as urban agriculture blossoms here, and you know, as we get into it and expands, I'm sure we're going to get a little bit more information on how to do hoop houses and small gardens.